St. Joseph's College for Women Autonomous Vishakhapatnam. Welcome to St. Joseph's open web-based learning platform So eLearn for a soulful, enriching e-learning experience. Department of Physics, St. Joseph's College for Women Autonomous presents St. Joseph's massive open online courses in digital logic design, and it is a skill effective course for degree students. Dr. C.H. Praveen Babu, Assistant Professor, Department of Physics, St. Joseph's College for Women, Autonomous, Vishakhapatnam, Andhra Pradesh. In this video, we are going to discuss about digital logic design. In that, combinational logic circuits 1, the subtopic is design of half subtractor and full subtractor. Design of half subtractor and full subtractor. Learning outcomes from this topic: conceptual understanding, design and analysis skills, implementation and practical skills, application level outcomes. Subtractor. In digital electronics, a subtractor is a combinational logic circuit that can perform the subtraction of two numbers that are binary numbers and produce the difference between them. It is a combinational circuit, that means its output depends on its present inputs only. Although in practice, the subtraction of two binary numbers is accomplished by taking the ones or twos complement of the subtrahend and adding it to the minuend. In this way, the subtraction operation of binary numbers can be converted into simple addition operation, which makes hardware construction simple and less expensive. There are two types of subtractors, namely half subtractor and full subtractor. Design of half subtractor. The half subtractor is a combinational circuit which is used to perform subtraction of two bits. Characteristics of half subtractor. A half subtractor is a combinational logic circuit that have two inputs and two outputs. Those are difference and borrow. The half subtractor produces the difference between the two binary bits at the input and also produces a binary output if any. In the subtraction a minus b, a is called minuend bit, b is called the subtrahend bit. Half subtractor truth table is as follows. We are having two inputs and two outputs. When both the inputs a and b are zeros, we won't get any output. That means both difference and borrows are zeros. If a input is 0 and b input is 1, then we'll get both the outputs as ones. If a is 1 and b is 0, the difference output is only active. When both the inputs are ones, we won't get any output. Half subtractor logic circuit. Here in this logic circuit, we are having two inputs a and b, and here we are using one exclusive OR gate, one NOT gate, one AND gate, and the output of the exclusive OR gate is difference bit and the output of the AND gate is borrow bit. The half subtractor's block diagram is as follows. This is the block diagram, and here we are using two inputs a and b, and we're getting the two outputs as difference and borrow. Hence, from the logic circuit diagram, it is clear that a half subtractor can be realized using an XOR gate together with a NOT gate and an AND gate. In the half subtractor as shown in figure, A and B are the inputs, D and B out are the outputs. where D indicates the difference and B out indicates the bar output. The bar output B out is a signal that tells the next stage that one has been borrowed. Operation of half subtractor. Now let us understand the operation of a half subtractor circuit. Half subtractor performs its operations to find the difference of two binary bits according to the rule of binary subtraction, which are as follows. The output borrow of B is 0 as long as the minute bit A is greater than or equal to the subtrahend bit B, that is AB. The output borrow is a 1 when A is equal to 0 and B is equal to 1. From the logic circuit diagram of half subtractor, it is clear that the difference bit D is obtained by the exclusive OR gate operation of the two inputs A and B, and the borrow bit is obtained by AND operation of the complemented of the minute A bar with subtrahend B. Boolean expression for half subtractor. The sum of products SOP form of different and borrow is as follows. Difference is equal to A bar B plus A B bar, that is equal to A n circle B. This is the output of the exclusive OR gate. Borrow is equal to A bar B is equal to A bar B, and this is the output of the AND gate. Advantages of a half subtractor. It is simplicity. The half subtractor circuit is simple and easy to design, implement, and debug compared to the other binary arithmetic circuits. Building blocks. It is used as the building block that can be used to construct more complex arithmetic circuits such as full subtractor, multiple bit subtractor. And it is low cost. The half subtractor use only a few gates, which reduce the cost and power consumption compared to the more complex circuits. Easy integration. The half subtractor can be easily integrated with other digital circuits and systems. Disadvantages of half subtractor. Limited functionality. The half subtractor can only perform binary subtraction of two single bit numbers respectively and not suitable for more complex arithmetic operations. Means if we use more than two inputs, we cannot use. Insufficient of multi-bit number. For multi-bit numbers, multiple half subtractors need to be cascaded, which increases the complexity and decreases the efficiency of the circuit. High propagation delay. When cascaded for multiple bit operation, the cumulative propagation delay of half subtractor becomes higher compared to dedicated multi-bit subtractor. Example, using a look ahead barrow. Here are the some of the applications of half subtractor. It is used first in calculators. Most mini computers utilize advanced rational circuits to perform numerical tasks. A half subtractor can be utilized in a number cruncher to detect two parallel bits digits from one number. And this is also used in alarm systems. Many cautions frameworks utilize customized rational circuit to identify and answer interloper. A half subtractor can be utilized in these frameworks to look at the upsides of two parallel pieces and trigger a caution in the event that they are unique. And this is also used in the automotive systems. Numerous advanced vehicles utilize computerized rational circuit to control different capabilities like the motor administration framework, stopping mechanism, and theater setup. A half subtractor can be utilized in these frameworks to perform computations and examinations. And this is also used in the security frameworks. Advanced rational circuits are usually utilized in security frameworks to identify and answer dangers. A half subtractor can be utilized in these frameworks to look at two double qualities and trigger a caution in the event that they are unique. And is also used in the computer frameworks. Advanced rational circuits are utilized broadly in PC frameworks to perform estimations and examinations. A half subtractor can be utilized in a PC framework to detect two paired values from one other. The K-map for half subtractor is as shown below. This is the K-map for difference bit. Difference is equal to A bar B plus A B bar. And this is the K-map for borrow bit B, and borrow is equal to A bar B. Design of full subtractor. The full subtractor is essential because a half subtractor can only subtract the least significant bit LSB of a binary numbers. However, if a borrow is generated during the subtraction of the LSBs, it will affect the subtraction in the next stages. A full subtractor handles this situation by considering the borrow from the previous stage, ensuring accurate subtraction even when a borrow is present. A full subtractor is a combinational circuit used to perform binary subtraction. It has three inputs. First input is A acts as minute, second input B acts as subtrahend, and third input B in borrow input from the previous stage. It provides two outputs, difference D, the result of the subtraction. Borrow output B output indicates if a borrow is needed for the next. For full subtractor is as follows. Here we are having the three inputs and two outputs. Inputs are A, B and B in. B in means borrow in, and we are having the two outputs, difference D and borrow output B out. We are getting no output when all the inputs are zeros. We will get the output when at least B in bit is 1. We are getting both the outputs as ones. When the input B is high, we are getting the output difference and borrow output. When B and B in both are high, we are getting borrow output. And when A is 1, we are getting the difference output. When A is 1 and B in is 1, we are getting no output. When A is 1 and B is 1, here also in this condition we won't get any output. When all the inputs are high, means all the inputs are ones, we're getting both the outputs, difference and borrow output. Logic circuit for full subtractor. This is the logic circuit for the full subtractor. Here we are using, in this we are using two exclusive OR gates, two AND gates, two NOT gates and one OR gate. Here for first exclusive OR gate we are giving the inputs from B, A, B, and from the output of the first exclusive OR gate it is giving to the input to the second exclusive OR gate, and to the second exclusive OR gate one more input is coming from the borrow input. Next same inputs A and B are giving to the AND gate. From A we are using NOT gate and it is giving to the AND gate, first AND gate. And to the next second AND gate, the output of the first exclusive OR gate is inverted and it is given as one input. and the second input is giving from the borrow in directly to the second AND gate. So both the outputs of the AND gates are given to the OR gate, and the output we are getting from the OR gate is borrow out. This is the full subtractor block diagram. In this block diagram, we are having three inputs A, B, and borrow input, and we are having the two outputs difference and borrow output. Boolean expression of full adder. The sum of the products SOP form the difference and borrow are as follows. Difference output D we're getting as A bar B in plus A bar B bar in plus A B bar B in bar plus A B in, that is equal to A n circle B n circle B in. This is the output of the exclusive OR gate. Bar output B out will get as A bar B plus B in A bar and circle B in B bar. In this condition, uh, finally we are getting as A bar B plus, we are taking B in bar common here, and we will get A n circle B bar. This is the output of the AND gate. Operation of full subtractor. Now let us understand the operation of a full subtractor. Full subtractor performs its operation to find the difference of two binary numbers according to the rule of binary subtraction, which are as follows. In case of full subtractor, the ones and zeros for the output variable difference and borrow are determined from the subtraction of A, B in. From the logic circuit diagram of full subtractor, it is clear that the difference bit D is obtained by exclusive OR gate operation of the two inputs A, B and B in, and the output borrow B out is obtained by the NOT gate, AND gate and OR gate operation of variables A, B and B in. Advantages of full subtractor. Borrow handling is first example. Unlike a half subtractor, a full subtractor can accept a borrow in from the previous stage, allows the accurate subtraction and multi-bit numbers. Cascadability. Multiple full subtractor circuits can be cascaded to perform subtraction on binary numbers of any length. For example, we can construct a 4-bit, 8-bit and 16-bit, reduces circuit complexity and size. By integrating complex logic into a single unit, full subtractor reduces the overall component count in digital systems, leading to the higher device density and high speed computation. Full subtractor are essential for fast, parallel, and effective arithmetic operations in ALUs, CPUs, and GPUs. Power efficiency. Modern implementations such as those used in FET provide low power consumption, which is critical for high performance computing and portable devices. Versatility. Beyond the simple subtraction, they are used for performing various arithmetic operations in the digital calculators and digital signal processors. Disadvantages of full subtractor. High circuit complexity. Full subtractor requires more gates and connected compared to the half subtractor, increasing the design complexity. Propagation delay. The sequential nature of borrowing across multiple stages creates propagation delay, resulting in parallel speed or slow performance in large scale operations. Increased power consumption is one more disadvantage. The complex multi-gate architecture leads to high power consumption, which is a disadvantage in power sensitivity multi-bit applications. Design and cascadability issues. As bit size increases, scaling full subtractor circuits for wide data path requires significant complexity and cost resource allocations. High cost. Due to the increased number of components, implementing full subtractor in large digital systems increases overall hardware cost. Applications of full subtractor. It is used in the operation of arithmetic logical units with CPU and GPU architectures to perform binary subtraction. Multi-bit subtraction. Unlike half subtractor, full subtractor can be cascaded to subtract binary numbers with multiple bits by handling borrow in and borrow out. It is also used in digital signal processing. DSP utilizes in specialized processors for arithmetic operations or signals. Microcontroller and timers employed in processors for computing addresses, timers, and program counters. Digital devices found in various calculators and portable digital systems. And it is also used in quantum computing. Nowadays, we are using this quantum computing used in design of quantum digital circuits for multipliers, dividers, and floating point operations. The K-map for full subtractor circuit is shown below. This is the K-map for difference output. We're getting the output D as A bar B in plus A bar B in bar plus A B in bar plus A into B in. And this is the one more key map for the bar output. Here the bar output is equal to A bar B plus B in into A n circle B whole bar. From this design of half subtractor and full subtractor, what we learnt are functional understanding, logic and Boolean algebra, circuit implementation and applications, and advanced concepts.